Hello, everyone. My name is Marcy Samuelson, and I am Marketing Manager for the Developer Initiative here at Oracle. Thank you for attending today's webcast, Incorporating DevSecOps into Oracle Container Engine for Kubernetes with Checkpoint's CloudGuard. We are very excited to be able to share with you the ways in which Checkpoint's CloudGuard can protect your apps and APIs with Oracle Container Engine for Kubernetes. If you have any questions during the workshop, please put your question in the Q&A area, and we have a number of technical experts who will try and answer them as soon as we can. We will also have a live Q&A session after the presentation. This webcast is being recorded, and we will make it available shortly after the webcast concludes. Again, thank you for joining the webcast today. I am joined today by Mark Nichols, Cloud Alliance Architect at Checkpoint, Rolando Penez, DevSecOps Architect at Checkpoint, and Sherwood Zurn, Product Manager at Oracle. At this point, I will turn it over to Sherwood.
Thank you, Marcy, and thanks to all of you who have decided to spend the next hour with Oracle and Checkpoint. I am Sherwood Zurn, Product Manager at Oracle. We also have Mark Nichols and Rolando Penez from Checkpoint to be with us today. Prior to their presentation, I would like to take a couple minutes to discuss Oracle's Container Engine for Kubernetes, also referred to as OKE. However, before I begin in that presentation, I'd like for everybody to take a couple of seconds to read the Safe Harbor Statement from Oracle. So let us begin. So first off, Oracle's Kubernetes as a Service, also known as OKE, is a fully managed, scalable, and highly available service that you can use to deploy your containerized applications to the cloud. Oracle Kubernetes, based on the upstream version supported by the Cloud Native Computer Foundation, CNCF. So we have no vendor lock-in, and that also means that everything you have tested with Kubernetes on premises can be ported to OKE without the need to re-architect it. So use OKE when your development team wants to reliably build, deploy, and manage cloud-native applications. Oracle's cloud-native services leverages highly performant next-generation Oracle Cloud Infrastructure, also known as OCI. These services can be categorized into application development and operations and observability and messaging. For example, Oracle offers a streaming service which is fully Kafka compatible, logging with FluentD, native monitoring, notifications, events, API gateway, infrastructure as a code that allows you to run your own Terraform stack in the cloud through our Resource Manager UI, functions and several other services that will assist you with managing your demanding workloads. And since OCI and OKE are based on open standard services, you're more than welcome to bring your open source software that you're familiar with to use along with Oracle Cloud Native Services. Oracle is a platinum member of the Cloud Native Computing Foundation and a member of the Open Container Initiative Linux Foundation project. So we are very serious about using open standard services and supporting the Linux community in general. Oracle is the only major cloud provider to deliver and support a unified cloud native solution across managed cloud services and on-premises software, supporting seamless bidirectional portability of cloud-native applications built anywhere on the framework. For example, applications running on WebLogic on premises can be easily containerized and then lifted and shifted into Oracle Container Engine for Kubernetes without re-architecting and rewriting any code. This makes the migration to the public cloud very easy. Terraform configurations can be used across Oracle Cloud environments, so they can be modified to be used in other cloud environments and also be automated with Oracle Cloud Resource Manager UI option for Terraform stacks and so much more. Oracle's second generation cloud infrastructure, known as OCI, provides bare metal, virtual machines, containerized compute, GPUs for performance intensive workloads, such as for AI, ML, and a variety of cloud storage options like block, object, file storage, and archive. OCI offers a fantastic array of services for developers to build modern applications, and OKE uses OCI as the main platform for its services. Regarding to the framework and programming options, Oracle doesn't restrict users to one or two programming languages only. So you have the choice to use any programming language and framework like Java, JavaScript, Node, Python, Ruby, Go, and various others, and you can use any DevOps tool as well. In addition to that, Oracle provides a set of free tools like Visual Builder Platform for your DevOps framework, but you can also use the ones you're already familiar with. So let's talk a little bit more about OKE and OCIR. Oracle Container Engine for Kubernetes is a developer-friendly and enterprise-ready managed service that runs highly available Kubernetes clusters with the control, security, and performance of Oracle Cloud Infrastructure while keeping pace and compatibility with the CNCF ecosystem. The Oracle Cloud Infrastructure Registry, also known as OCIR, is a highly available container registry service that enables users to easily store and share their container images. OCIR allows users to push and pull images with the Docker CLI or pull images directly into the Oracle Container Engine for Kubernetes deployments. OCIR is Docker v2 compliant and can work with OKE or other container engines as well. So let's look a little bit at the OKE OCI pricing and packaging. If you look at the stuff, the gray shaded area, you can see that OKE and OCIR includes the OCIR registry and OKE. And then that is the managed portion of the service. The stuff on the right, which is the customer's tenancy, the account, this is what the customer manages. The gray shaded area is all that is what Oracle manages, and the customer does not have to be concerned about that piece. Oracle will manage the etcd and master nodes of the Kubernetes instance in a high availability setup for the customer. Upgrades to new versions of Kubernetes will also be supported in the Container Engine dashboard within the OCI console. So it's very easy to upgrade your OKE master node along with your node pool servers, and you decide when to mitigate downtime situations. Users will manage the clusters and the worker nodes that are set up by the managed service in their own OCI account and tenancy. Users do not pay for any of the Oracle managed container infrastructure. This is known as the control plane and enables you to configure these services, maintain operations, versions, availability. Users pay only regular fees for the compute, storage, and networking used in the data plane. That's the area in the blue on the right. In addition to OKE and OCIR, Oracle offers many other cloud-native services. One of those is the service broker for Kubernetes. With the service broker, you are able to easily provision an autonomous database, ATP, autonomous data warehousing, object storage, or streaming. The main key benefit of the service broker is reducing the complexity in the app deployment. So it's very easy to get your OKE's microservices talking to other Oracle Cloud services that your application requires. Obviously, there are situations in your application where you need a you need to have persistence. There are obviously two types of, you can imagine, of stateless and stateful applications. Your stateless apps do not require persistence. They're easily redeployable and easily scalable. They can be easily containerized. That for stateful apps, they do require persistence and they're more useful for complex use cases. OKE provides services and capabilities for both stateless and stateful apps. And along with that, you have the capability to integrate your apps with Oracle's flagship autonomous database and storage services like block and file storage services. So let's look at some of the recent updates that have been made to OKE. So for instance, right now, Kubernetes, the current version for OKE is 1.18.10. Now, the total on the open source community, it's 120. Now, the reason why Oracle always maintains a release or two back is they want to make sure everything is vetted, and so that the customer has an excellent experience when using the OKE. The other aspect of that is the Cloud Shell, and that's a web browser-based terminal accessible from the Oracle Cloud Console with several useful tools and utilities pre-installed. That would includes things such as Git, Java, Python, kubectl, Helm, Maven, Terraform, Ansible, SQL+, and others. This prevents you as the customer from having to install all those things. If you want to access your Kubernetes cluster from local, then you wouldn't be required to install the vast majority of those tools. With the Cloud Shell, Oracle does that all for you. Cloud Shell is also integrated with OKE and functions, so that means you manage your OKE clusters and functions directly through that UI. The other aspect is pod security policies, which control the operations that pods can perform on a cluster you have created with container engines for Kubernetes by setting up pod security policies for the cluster. In addition, the other thing I want to point out is autoscaler, versus particularly the horizontal pod autoscaler, the vertical pod autoscaler, and the cluster autoscaler. At this time, the cluster autoscaler is not in the OKE, how it will be within the next couple of weeks. With that, I would now like to turn the time over to Mark Nichols from Checkpoint. Mark, take it away.
Hello, this is Mark Nichols. I'm a Cloud Alliance Architect with Checkpoint, and today we're going to talk about CloudGuard AppSec, or protecting your web applications and your APIs in a DevOps world. We're going to talk about why you need AI-driven protection for your web applications and your APIs. We'll take a look at the CloudGuard AppSec approach to doing this. We'll go through a sample Kubernetes deployment architecture and talk about how this can easily be applied to your existing application infrastructure. And then we'll take a look at a quick demo. The need for protecting your applications and your APIs continued to grow last year. One report showed that there was a 51% increase in attacks against healthcare-based applications just between November and December of 2020. The Verizon Data Breach report showed that there was an increase of 43% of breaches that could be traced back to application security, more than double the results of the previous year. If you've tried to protect your applications or your APIs with traditional application security products, you're already aware that most of them are signature-based. They don't provide contextual analysis for the way the application might work, and typically they generate a very high rate of false positives. This leads to a lot of administrative overhead for managing the security protection for your environment. A modern application security solution has to address a lot more issues than what we've traditionally looked at. For example, the CI/CD pipeline means that we can have new releases on a very frequent basis. So your protection has to be able to adapt to the changes in the application without you having to reconfigure the environment. The protection has to be a multidimensional security analysis. It can't just cover the typical functionality that you would have in the application. The next concept that has to be included is what we call precise prevention. We don't want to have to take a look at each individual behavior and create a rule associated with that. And finally, this administration has to be fully automated. It has to understand what's happening in the environment and be able to protect it, even though there are changes, whether it's to new application functionality, extensions to the schema, or new forms of attack that we know that are coming against your applications. So let's take a look at how the CloudGuard AppSec product protects your environment. The three capabilities that we're going to talk about are a cloud-native web application firewall, API security, and bot prevention. The first one is that the CloudGuard AppSec product provides a very sophisticated advanced web application firewall that protects your environment from the top 10 OWASP attacks. This includes things like SQL injection attacks or cross-site scripting vulnerabilities. The second category that CloudGuard AppSec provides is API security. In the DevOps world, not only is it common for us to extend the schema of our APIs, but we make changes to the way the application works and we add new APIs on a regular basis. CloudGuard AppSec protects your applications and your APIs through a variety of ways. The first one is that we provide schema validation to make sure that the API calls are meeting the requirements of what you have. The second is we're applying what we call contextual artificial intelligence that we'll talk more about in terms of the way we look at the API calls to make sure that they're not doing things that they shouldn't be doing. The third category is what we call bot prevention. We're able to analyze the way a bot may attack your environment and prevent that attack from going forward. All of this is done with a very powerful contextual AI engine. So let's take a look at some of those use cases now. When it comes to protecting your web applications, CloudGuard AppSec applies a two-phase analysis to your environment. First is a lightweight evaluation for non-malicious traffic, and then a deep analysis based on 3 AI engines. These AI engines do things like user reputation scoring, an application awareness scoring, and an indicator scoring that are typical of what we know as indicators of compromise. The great thing about this contextual AI environment is that there's no requirement to manage the rules and list. When it comes to protecting your API calls, we're applying what we call positive security and negative security. In the category of positive security, we're validating the API call against the open API schema that you've already defined to make sure that it's including the required fields and it's adapting to the APIs that you've made available in your environment. When it comes to protecting for negative security, we're using our artificial intelligence engine to protect against command injections, API key extraction, or the exposure of sensitive data. To protect your environment against bots, we're doing something called client-side behavior analysis. That's where we analyze your application to see what typical behavior is like, and we define a normal pattern of interaction that is associated with the website. Then we're able to detect how a bot is behaving. This allows us to prevent things like reconnaissance or scraping, or even token cracking, just by being able to distinguish the way a bot behaves versus what we consider to be normal application behavior for the application. The CloudGuard app selection can be deployed in different scenarios. It can be deployed as a virtual appliance that's protecting your environment. It can be deployed as part of a SASE capability from the CloudGuard Checkpoint Cloud. It can be deployed and integrated with an existing proxy agent or reverse proxy agent like Nginx, or it can be deployed as part of a Kubernetes container deployment. So here are some of the components of what it would look like in a Kubernetes environment. At the bottom of this diagram on the right-hand side, we assume, first of all, that you have an existing Kubernetes application that you've already been working with. We've defined a couple of pods here that represent a unit of work associated with your environment that may have one or more containers. Those pods are being exposed through a service definition. In this case, it's my app-service. What we're adding on top of that is the Kubernetes environment for CloudGuard AppSec. We've simplified the deployment of this with a Helm chart. The Helm chart provides several different YAML files associated with the configuration. The first one at the top is what we call the service.yaml file that has the definition for a node port load balancer solution in front of the worker pods that are protecting the environment. The second component is the pod that has two containers. We've got an Nginx deployment along with the Checkpoint Nano agent that's associated with this. And then we define the ingress rules that allow us to map the inbound traffic to the service that you've already defined. One of the key components that are required for this is what we call the InfinityNext portal token. When you define your application in the InfinityNext portal, you obtain a token that you can deploy this Helm chart with. And what that allows you to do is pass the traffic, the inbound traffic, into the CloudGuard environment, the cloud-based service that protects your application. Let's take a look at a quick demo with this using the Juice Shop application. The Juice Shop application is an open source application that's used to train programmers on OWASP vulnerabilities. We'll deploy one of these in a Kubernetes cluster, and then we'll go through the Checkpoint Infinity portal configuration that I mentioned earlier, and then we'll deploy this with Helm. For this demo, we'll create a Kubernetes cluster in the Oracle Cloud infrastructure using the default settings. Now that we've established a Kubernetes cluster and established our connectivity through the command line, let's take a look at the environment that we've created. So this cluster has 3 nodes available. I've also created a test namespace in order to do our deployment. And now we'll deploy the Juice Shop application so that we can establish the architecture that we previously referred to. Remember, the architecture assumes that there's an existing Kubernetes application. The YAML I've defined for the Juice Shop application contains a very simple deployment of one container with one pod with one container, and it also defines a service. We see here that the pod has been deployed with the Juice Shop application and that it's established an internal cluster IP address for the service. Next, let's deploy the Checkpoint CloudGuard AppSec through the Helm chart environment. In this command, we see a Helm install with the name of the Helm chart that we're going to deploy, the Helm deployment file, the namespace that we're deploying to, the nano token that I've downloaded from my portal environment from Checkpoint, the URL that the service is listening to, the juice-shop at checkpoint.checkpoint.com, the service name that we've identified in the Juice Shop YAML file, and the service port that that Juice Shop is listening to. And you can see above that it's listening on port 8080. While this is deploying, we'll take another look here at the architecture, and we've got the Juice Shop application defined below as our existing Kubernetes application. We've only got a single pod with a single container, and we've defined our service listening on port 8080. And then above what we have is the Helm chart that's deploying the Checkpoint Ingress Controller service, the pod with the Nginx reverse proxy that's calling the Checkpoint Nano agent, and the ingress rule. We'll give this just a moment to complete the deployment process, and we'll find at the end of the deployment process that there will be an external IP address defined. Now, I mentioned earlier that we had the Checkpoint Nano token. Let's go into the Checkpoint InfinityNext portal to see how that was defined. In the Checkpoint Infinity portal, we've defined an asset, which is our web application, the Juice Shop. And what we've done here is we've defined the URL that it's going to be listing on and any of the parameters that are associated with this. We've also defined a policy that contains rules, practices, parameters, and triggers for configuring the Juice Shop protection that we would like to apply. Please check the CloudGuard Infinity Next or the CloudGuard AppSec deployment guide for what those parameters should look like. In the enforcement section of the Infinity Next portal, where we define the profile for this environment, is where we establish the token that we deploy with our Helm chart. Since this is a test environment, I'm going to update my local host file with the IP address of the external agent in order to do the testing with. So this is the IP address that I'll add to my local host file in order to do our testing with. If you're already familiar with the OWASP Juice Shop application, you know that it has tested here to see if you can do things like a SQL injection attack. So let's take a look at what that SQL injection attack might look like. And in this case, if we were to do a database select with 1 = 1, if you have the Juice Shop application that you've normally deployed, what you'll find is that it returns the results of all the login information from the database table. But now, because we have the Checkpoint Application Security or AppSec product in place, it's blocking that SQL injection attack. So let's take a look at this in the Infinity portal. We'll go into the operation section of the Infinity portal, and we'll take a look at the events that are associated with this. And we'll see here that the Juice Shop application has been protected from a SQL injection attack. In summary, you have an opportunity today to protect your web applications and your APIs with the CloudGuard AppSec product. It's an effective tool at providing this protection, and it's very easy to deploy with Helm charts. For the next step, we would like to recommend that you get in touch with your cloud security architect for a one-on-one demo and start your free CloudGuard trial.
Thank you, Mark. Now we will turn the time over to Rolando Panez, who will then talk about another aspect of Checkpoint. Rolando?
Thank you for joining me. My name is Rolando Panez, and I'm the DevSecOps architect for Checkpoint Software. And today I'll be talking to you about our container security and how you can use it to secure your Kubernetes environments within Oracle Cloud. So first step is posture management and visibility, right? How do we know what's going on within the Kubernetes environment and configure things correctly, right? And how can we ensure that that configuration is met over time? Okay, so as part of this posture management, you want to be able to optimize your configuration. So you need that continuous assessment, right? You want to be able to align with the security best practices, and then also have the ability to build your own rule set. For example, when building your own rule sets, we use a GSL language. It's a very, very easy to read language. And again, as part of the demo, I will show you how to quickly build these rules and even add your own context to the rules and that make more sense for your environment. Around container visibility, right? There aren't any native flow logs within the Kubernetes environment. We generate our own flow logs and use that to inject the metadata into these logs and give you visibility around your environment so that you understand how things are connected, and also if there are any vulnerabilities or vulnerable connections being made from your containers, right? For example, in this use case, you can see that a database has direct internet connection, and so you can find those types of misconfigurations, build alerts around it, and automatically get alerted if this occurs again. Finally, I'll show you how the reports and dashboards within the platform are very easy to use. Different teams want to focus on different areas, on different types of assessments. right? How can I find the information I'm quickly looking for, and how can I build reports for that environment very quickly? Here's a summary of one of the reports. Again, you can get as very detailed as you want, or maybe you want to keep it high level for an executive level report. So on to the demo. So the CloudGuard native platform is a SaaS platform. So everything will communicate back to the CloudGuard native platform, and that's where all the reporting and assessments are being done. So as part of onboarding your Kubernetes environment, so here's a Kubernetes cluster that's been deployed via OKE. In order to do this, I actually leveraged the great Oracle Cloud modules, right? And I have a GitHub that that contains a simple cluster to be deployed. If you follow this and set up the correct permissions or the correct values, right? I've leveraged the OKE modules, as well as in my case, I wanted to do everything very simply. So I have the Kubernetes provider as well that I use to deploy an application, the Helm provider that I use to onboard the cluster into CloudGuard, and then also the CloudGuard provider. So as far as onboarding, it's a very simple process. When you onboard the cluster, we leverage Helm to deploy the different agents and daemon sets. You run this Helm chart. I did it via Terraform, and then it will onboard, and everything will get deployed. We can see here there's active communication between the cluster. I can show you within the cluster itself. I ran some commands here. I did the get pods within the checkpoint namespace. And again, you can see the flow logs and the inventory agent that are running. I also have a Terraform example application, which in this case was just Nginx, right? And then the service associated with that project. So from here, once it's been onboarded, the first step of visibility that we get is seeing what's within the clusters, right? So if we click on the Protected Assets tab, we can quickly see all the daemon sets, the different deployments, the different namespaces, the nodes, right? And any Kubernetes pod that's been deployed. Again, this is my Terraform example that I'll be showing. We can look at that IP from that service. We can see that this should be up and running. Okay, so we can go to that page. Okay, we can see Nginx is up and running. Okay, so let's go back and let's see the visibility that we're getting with the CloudGuard native platform. Okay, I can actually go here to Protected Assets, and this helps you to quickly filter through and find what you're looking for. So in my case, I'll start filtering by the Kubernetes platforms. I want to add a filter here for my actual environment, right? Or I can type it in here. I know it's named Informed Mako. Okay, so this is the one that I'm interested in. All right, and you can easily build out your different queries. Okay, and you can save these filters for future uses. Okay, again, this is nice. You get everything from your cluster. You can export all of this information by filtered, right? And then if you want to look at anything, let's say, for example, we want to look at this deployment. Okay, and we can see everything. We can look at all the metadata associated with it, labels, right, tags. Okay, if we want to go back, we want to look at some of these pods, right? In this case, I'll look at the Terraform pod itself, everything associated with it, so we can see any network policies, tags, right? And again, and shortly, I'll show you how you can build rules to search for any of these fields within the different components. Okay, so first step we want to do is, again, understand. All right, I have my cluster deployed here. How can I ensure that this cluster is properly configured? So I'll go to posture management. We do have some rule sets out of the box. You can take your CIS benchmark, version 1.6, or if you want to use some of our CloudGuard best practices. I'm going to start with the CIS benchmark. It's a good place to start. As we go through here, we can see, let's add filter, and let's look at the different types of things that we're checking for. So we have quite a few checks here for Kubernetes nodes, for Kubernetes pods, Kubernetes security policies, right? Kubernetes roles, service accounts. And then notice when I select any of these, and you see the rule here that the GSL associated with it. Okay, so again, this is the language used to build these rules. Very simplified language, and I'll show you how we have that the rule builder to help you get started. Okay, you also have a reference to the documentation we use to build these different rule sets. Okay, so I'll run this assessment, and here is that first step of the reporting. Right, so overall score 85%, so 393 out of 458 passed tests, pretty good. Okay, now we can go through, again, we can show the rules, or we can show the results by rule, or we can show it by particular entities. And so now we can filter on those different entities if we know what exactly we're looking for. So I can add filter types. All right, okay, so let's focus just on the pods. All right, so now I get all the results around the different pods and how they fail. Okay. As I expand some of these, I can see the different rules that failed. See, in this case, this is a bad use case. I use the default namespace for my pod. You know, it's a low thing, but you typically shouldn't do that, right? You want to use namespaces that mean something, so you can isolate your resources correctly. Okay. Now again, this report can be exported. Maybe you want to have an executive summary. Okay, a very high level report. Again, it shows how much failed, how many passed, the failed tests by severity. So most of them, from here you can tell most of them were very low or informational. And again, you can go through and you see all these, the ones that have failed, and the high ones. Maybe you want to just ensure or focus here on the high ones when you're trying to resolve them. So this is great. We have our rule set. We have a good baseline here based on CIS. Now we also want to have our own custom rule sets, right? So let's go ahead and create our own rule sets. And so we will go here. We're going to add a rule set, and we'll select Kubernetes. Go ahead and create this. Okay. Now we're going to create a new rule in here, and we'll start by creating this GSL rule. Now notice, we don't have, we're not very familiar with GSL, right? It's with any language, right? There's going to be some sort of learning curve. So back to our example here, where you know, we wanted to create that rule, ensuring that pods use a network policy. Okay, so I can say Kubernetes pod, okay, should not have network policy, ingress is empty, and network policies egress is empty. Right. And again, I mean, if I have values, right, I'm just checking that that they're not empty. I'm checking that something's being used. If you know, if there's a particular value that I want to use, then I can also put that. Another thing I can do is say, you know what? Yeah, this is important, but I'm only interested in this case if it's in a production environment, for example. So I can say Kubernetes pods where. And again, if we have tags, or we're using tags, or we're using a particular namespace, right? You know, that's how we can identify them, but we can filter down this rule to a particular scenario. So let's say, you know, if things are in a particular namespace, where namespace is equal to default, right? Add should not have our network policies ingress is empty, and network policies egress. And then I can test it. And so we have 3 that are non-compliant. I expand this. We can see that the pods that I had deployed around my example pod is these all failed, right? And if I look through the metadata again, I can see that the namespace here is default, and my network policies are actually empty. Okay, so this is how we test these rules, right? Now I want to apply this continuously, right? I want to ensure that, first of all, we're doing the CIS, you know, the CIS Kubernetes benchmark continuously. So we can go here to continuous posture and create a policy to do this, right? So I'm going to go here, add policy. for a particular environment. It's going to be Kubernetes. Next. And then the environment name. Oh, I found it here quickly. So I'll just click that. And notice you can select multiple environments, multiple clusters, right? Again, I want to do that CIS benchmark. That's my, that's my baseline that I created. And then, I also want to do my custom rule set, right? I added that custom rule set with my resource limits. I'll click next, right? And then I'm going to add a notification policy. So this is a very powerful area within the CloudGuard native solution, where we can send reports to different types of tools of the built-in alerting console. We can do via email, or let's say HTTP endpoint is a very, very popular way to support different tools like Jira, Sumo Logic, ServiceNow, Splunk. But basically anything that supports HTTP endpoint, Microsoft Teams, anything of that nature, we can send alerts to those tools. Okay. And so you want to get these alerts out to the appropriate team members, right? So maybe you want to create a different alert policy for different clusters. You can do that. You can be very granular in how you alert your team members. All right. So again, we're going to. I already have some of these set up, so I'll just do the alerts notification, and then I'm going to go ahead and save that. We have these two rule sets that have been configured to constantly run, and this is my alerts notification. The next thing I want to do is that visualization, right? How is everything interconnected within my pod, right? And so now we see all the logs. Again, you get an idea of what we're pulling in here. Notice all the metadata that we're injecting into these logs, right? This information makes it easy to actually map this out. And we actually group them, right? If we want to group things by the namespace, again, here's that default namespace, some of the resources I had in there. Here's a checkpoint namespace, and those resources and how they're communicating to, basically they're communicating to the CloudGuard platform. So as far as the reporting capabilities, again, I discussed the reporting around the posture assessment, but we have some default dashboards that can be built out, right? And any of these widgets you can actually customize. So I want to thank you. I hope this was very informative, and thanks again for your time.